Okay, so now I will go over question 21. So the first concept in question 21 is kinematics. And I've already gone over this a bit, but basically it is basically kinematics is the study of motion without looking at forces. So studying of velocity, acceleration, displacement and time without looking at the forces that cause that motion. So it's basically like the simplified version of just knowing motion before going to the complicated stuff like forces and things like that. Okay, so this question is going to deal with the kinematic equations. The next concept I'm going to go over is when something is in free fall. So, when an object is in free fall, there is both movement. So we have to look at both movement in the x direction and in the y direction. So I'm just going to draw a little picture here. This is a ball being thrown into the air. So this is the ball. It's being thrown into the air. And for the velocity in the y direction, velocity is going to increase, and then it's going to decrease as it goes down, and then at the top here, the velocity in the y direction is going to be 0. Because, as you can see at the top, there's no movement in the y direction. So when we're looking at movement in the x direction, or horizontal movement, at the top, there will only be velocity in the in the x direction, not in the y direction. And movement in the x direction will stay the same throughout here. Only the movement in the y direction will change. So that means that for the vertical motion at the top it's 0, but in the x direction for the horizontal movement at the top, there will only be horizontal velocity at the top. Okay, so those are just the important concepts when looking at this question. Okay, so now I'm going to read question 21. A cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second and at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path is most nearly. Okay, so first what I'm going to do is I'm just going to draw this picture. I'll just draw a line here. So, it says, okay, so this is the horizontal, and it's being shot at 40 degrees above the horizontal. And we can just say that this is the ball being shot. So it's going to go this, and then go down. And this object is in free fall. Okay, so what we need to find is the speed of the cannonball at the top of its path. So, like I said before, when something is at the top of its path, there is no movement in the y direction. There is only movement in the x direction. So, that means that at the top, we're looking at the velocity just in the x direction. And since the horizontal motion stays the same throughout this, that means that the initial velocity will be equal to the final velocity. So that makes this problem pretty simple. So to find the initial velocity, basically, so they say it's being shot initially at a velocity of 25 meters per second. Okay, so we just need to find the initial velocity, and that will give us the velocity at the top. So basically, to do this, we're just going to do 25 times cosine of 40 degrees, because adjacent over hypotenuse. So, and that will give us the initial velocity, and that will be the velocity at the top, because it's only movement in the horizontal at the top. So this comes out, I already did the math, to 19 meters per second. So that is the correct answer. And basically I just found the initial velocity, and that showed me the final velocity at the top. And so then the answer to this question is C. So I'll put C here. So basically, in conclusion, this question showed an important principle that when an object is in free fall, so there's always movement in the y direction and in the x direction. We have to take both into account. And at the top of its path, an object is not going up, it's just going straight, so there will only be motion in the horizontal direction. So for these types of problems, it makes it very easy because if we already know the initial velocity in the horizontal, we'll know the final velocity at the top. Okay.